Station 51, engine 27, engine 32, truck 105.
You're listening to The Fire Break with Steve Wolf. Welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire. Check us out on the web at teamwildfire.com. I have got with us, live from California, Michele Barbato. And Michele is a professor at UC Davis. He teaches climate adaptation research, structural engineering, lots of really important stuff given what the planet's going through right now. So welcome to The Fire Break. How are you, Michele?
Doing great. Thank you for having me.
I'm so excited to get to chat with you. Tell me, what's going on in your research these days? What are you most concerned about or most focused on?
There are a lot of different things that are concerning and exciting at the same time. I would say that a big part of my research is on understanding how climate is affecting hazards and action on the built environment.
Okay.
And this goes through all of a series of different hazards from hurricanes, tornadoes, flood, wind, obviously wildfires, as you would imagine, since I'm on these podcasts. And so the first direction of my research is assessing what is the hazard, the vulnerability, and the risk associated with each of these hazards, and then trying to find ways to mitigate each of these hazards with technologies, materials, construction techniques that can be used for the built environment.
That's a lot of work.
Yeah.
So
Job
you've got
security, I guess.
one problem, right? And many problems, but simultaneously many solutions that you're looking at. So what are the ones that are most promising right now and that you think are most likely to survive budget cuts?
I don't have a crystal ball. That's a different type of question that I would have expected. I can
Okay.
say what are technologies that have the possibility of a big impact and that I'm working on.
Okay.
And I'll focus on wildfires. But
Perfect.
fundamentally, the idea is we have a very vulnerable built environment, particularly homes and small buildings. And there is an ongoing effort that is very important toward the implementation and advancement of construction and material requirements, and that's typically reflected in our Chapter 7A here in California for the building of homes and other structures. The thing that I'm working on is going beyond the idea of having homes that are ignition resistant and making them more fire resilient overall. And I guess I should explain a little bit what this means. Our current idea of protecting the built environment from wildfires is to have homes that can resist for 30 to 60 minutes to the action of embers, radiant energy, and direct contact of flame, because we are tendentially used to the idea of wildfires that are very quickly going through vegetation. And as if you can resist enough time, then your house will be protected. However, big fires like the one that we have been observing recently, the LA fires, but also the fires in Hawaii, and the year before the fires in Colorado, were conflagration fires or conflagration,
Yes.
where fundamentally the fire is moving from building to another building. And this brings two possibilities in terms of what we do to reduce the effects. One is we make structures that are more fire resilient, and the other is we start planning at the community level and not parcel by parcel like we have done so far. So going back to the original question of technologies, I've been working for about 15 years on nature-based solution for construction, and particularly on earthen buildings, structures that are built using mostly soil as the main ingredient in construction. The idea is to reinvent a technology that is really 10,000 years old with Adobe, Cobb, and Rammed Earth, using modern engineering and modern material science to use it in a way that is at least as safe over all of the different hazards for as the modern construction. More fire resilient in particular, but also more affordable and more sustainable. With the idea that any solution that requires additional use of resources instead of a reduction of the use of the resources is fundamentally an idea of maladaptation, as I like to call it, that is where you adapt to a changing climate, but you are producing a change that is faster, and then you will never reach the adaptation that you want because you're actually making it go away faster than you can reach it.
So fundamentally, the problem is that fire needs fuel, and we build our houses out of fuel.
Fundamentally, yes.
Yes, and if we build our houses out of something that's not fuel, like rammed earth or compressed earth, then it won't burn, right? In fact, when you expose rammed earth to more heat, it just fires like ceramic and gets more durable.
Yeah, actually, that the technology we are working on is called the compressed and stabilized earth blocks, which is fundamentally a modern version of Adobe, where the soil is mechanically compressed to increase the mechanical strength and the other mechanical properties, and is also stabilized with a small amount of chemical stabilizer that can be cement, lime. There have been other materials that have been used too, in order to improve the durability under weathering agents. We know that Adobe in a very humid environment tends to perform not as durably as we would like to have our houses. However, we have records and examples of earthen constructions that have been there for hundreds of years and that requires very minimal maintenance. And obviously, when you look at what happens after a fire, the only thing that doesn't burn is soil.
Right.
So if you build your house with that material, you have definitely a material that is not combustible. But as you were pointing out, we have done testing in our labs. We found that this material can resist to 7 hours at 1000 Celsius. Which
Wow.
is 1832 Fahrenheit. That is a very high level of temperature for a fire. Typically is higher than a vegetation fire only, and it's similar to the fire that you would get from a very close house burning to your own home. And fundamentally, what we obtained is that the unfired clay bricks that we were using became fired clay bricks, so they became stronger.
Yes, right. So let me ask you, what about the gap, right? Because I've been working with people who've been working on rammed earth, innovation, right? We're innovating by recreating something that's thousands of years old. But where do we bridge the gap between what looks successful in an academic environment and in a lab environment, and then actually getting adoption where people actually use this? Because I could imagine someone reads the report, they're all excited about rammed earth, and then they put the report down and they go out to Home Depot and they buy 2x4s and build their house. How do we get people to change the behavior, not just the knowledge?
So people would love to change their behavior. Just to report a little bit of data, and also the success that we have had so far with building codes. So recent research reports that the survivability of homes that were built before 2008, before Chapter 7A became fundamentally the law of the land here in California, was of the order of 10 to 12%. So 9 out of 10 homes that are subjected to some version of fire are going to burn. That's definitely not great.
No.
Now, we do all of the nice things that are required from Chapter 7A, including hardening, defensible space, even the Zone 0 defensible space that is becoming a hot topic right now that hopefully will be finally approved. And our survivability increases to about 50%, between 48 and 52%. Now, that's a 400% increase, so it's not nothing to sneeze at. It's a great result. But how many owners would be happy to know that if they do everything to their best, according to current rules, they have the same chance of having their house survive as winning a coin flip? Personally, I wouldn't be very, very happy.
Yeah, right.
So the overall idea of bringing it to this level of safety maybe needs to be revisited. And the way that people react when talking about fire resilient homes is they immediately think about a concrete bunker. And that is the thing that I was saying. We shouldn't do that because, if you use more resources, you end up that you need to adapt to a climate that is changing even more. So there are kind of some paths that we can take. And really there is an entire additional layer of complexity on this because what controls the safety of a home is then also what controls the capability of getting an insurance. We know that we are getting into an insurance crisis that can only get worse as not only climate changes, but also we use more and more of the wild and urban interface. We expand our construction in the wild and urban interface where the risk is higher. And finally, people in this area are starting to recognize that if you don't have insurance, you don't have mortgages.
Right.
If you don't have mortgages, no one is going to build the house anymore. And we already are like 5 million homes below the needs for the country and about 500,000 homes less built every year. So this gap is increasing. And we have homes that are getting more expensive and it's just not a good situation to be with.
No.
So there are probably two ways of acting on the real problem that is reducing the risk. One is fundamentally a managed retreat. But that is fundamentally saying we need to displace entire communities. And we know that that's not something that, first of all, no one is happy about it. And second, typically is not going to give us equitable outcomes because communities that are well off will find a way of staying there by doing something else. But communities that are already disadvantaged from economic or political reasons, they will be the first one to be told you need to move. So I cannot, even though it makes a lot of sense from an engineering point of view, I find it difficult to advocate for that as the only solution to our risk. Definitely, there are things that need to be done. There are levels of risk that are unacceptable, and there are tools that can be used to increase density and help people to be closer to the jobs that sustain their families. So it's a tool that needs to be used as all of the other tools, but has to be used carefully, not as when you are a hammer, everything looks like a nail. So the other direction is increasing our resilience of the built environment. And this can be done with the proper design of communities, addition of fire breakers, things like that. And then obviously with making our houses that are more resilient to wildfires. So if we bring our chance of surviving from 50% to 80%, this is a little bit like when you think about there is a pandemic or something like that, and there is a diffusion of a bad illness through transmission. Fire is fundamentally working like that. So is also like using a vaccine for wildfires. If you start having enough homes that are well protected from wildfires, they will be protecting the entire communities. So if I have to look at this, it seems like a very good investment of taxpayer money to do the research, investigate, remove the red tape that there is for construction types that are different than the typical wooden home, and start thinking a little bit outside the box, because otherwise we are just going to get in a worse and worse situation.
Yeah. When we think about fire breaks, we usually think of that as something we do between two areas of wilderness, right? We want to put the fire break between the wilderness that's on fire and the wilderness that's next to our house. But now we're maybe having to think about a fire break as something that we do within a community. When you have a housing density of 16,000 contiguous homes, you lose them all. So where are we on the idea of fire breaks within communities? You could confine a fire to a given neighborhood.
So this is not my field of expertise, so I
Okay.
would probably let other people knowing better all of these technology to respond to that question. But
But let's say
I
you had your
do, I think I can intelligibly say that it is a tool that needs to be considered and used where appropriately where it can appropriately reduce the risk. Because there is no single tool in our toolbox that will resolve such complex problems. We really need to affront it in a way that is more holistic, and use what we have available right now while we develop the tools for the next generation.
Yes. I'm wondering, like, if you were looking within a new community that you're putting up of thousands of homes, if every fifth house was a rammed earth house, in rows, then they would serve as breaks to stop, structure to structure conflagration.
I would love to actually have, almost all of the new houses made it with earthen construction. And again, earthen construction is a lot of different technologies. There is rammed earth, there is earth block construction, that is what I'm investigating, and I know better. There is cob, which is monolithic Adobe. So there are a lot of different technologies, but they all share some great advantages over more modern construction. That is beyond the material resistance to fire. They also have the capabilities of reducing your electric bill for heating and cooling. They use a physical phenomena that is different than what is typically controlled in our codes, that is fundamentally based on the R value for stationary conditions of temperature indoor and outdoor. They use thermal mass, which fundamentally, if you have ever been in a wine cellar, is the reason that there is always nice and cool during the summer and during the winter, and never too cold. Fundamentally, due to the changes in temperature between day and night, between seasons, you have that the heat from outside never reaches the inside, and then when it's colder outside, the heat is released back. And so you can keep a very nice temperature inside with very little use of air conditioning and heating, depending on the climate where you live. Only when, like if you're building in Colorado and you have 4 months of cold, then definitely you will need to turn on your heater for some time. And vice versa, if you are in a very humid and warm place like southern Louisiana, you will probably use your air conditioning once or twice a day during the summer. But it's very different than what is happening now, where you have your heater always on or your air
Right.
conditioning always on for 4 months, 5 months per year.
Yeah.
And in places like where I live in Davis, you can have a reduction of your electric expenses for heating and cooling of about 70%, because
Wow.
the difference between day and night is so big that fundamentally you never reach the need for turning on your air conditioning for most of the year.
Sure. So in order to do your research on this, uh, you have to spend a lot of time in wine cellars. Is that right?
But I wish it was true, but I could do that, definitely.
Right. And we talk about wine, the protecting the wineries from wildfire is another huge economic concern for people, right? The billions of dollars of wineries are at risk, both from direct fire and from smoke taint.
Absolutely.
Yeah. Does any of your research uh, influence that at all?
Um, I mean, again, my research is more on the built environment, so homes, buildings, critical infrastructure, that kind of things. There are colleagues that have been working on these aspects here in UC Davis, and I interact with them sometimes closely through the Climate Adaptation Research Center or through the Citrus Climate Initiatives, of which I am director, but that's not, again, my field of expertise. I
So
like
you work in
wine,
the built
but
environment. So when we walked through the woods in California 200 years ago, there were no wineries there, right? In fact, we brought the grapes from France to start the wineries. So is that a built environment, or it's not a natural environment? It's an agricultural environment, but we built it. So at what
well,
where's the line between an agricultural asset and the built environment, like buildings?
it's a question that probably will have different answers depending on who you ask it to. But my scope of the research is on buildings and infrastructural systems that we
I see.
physically build. And so I prefer not to go and take space from others because they can talk more intelligently than I could ever. And I can talk about how we make homes that are more resilient, how we
Yes.
protect, for example, hospitals from issues of smoke and things like that. But I I don't have the expertise uh, to treat the other types of problems, and that
Okay.
doesn't mean that they are not important. It's just
Right.
that
Right.
that's the reason that there are a lot of very good people that are investigating a lot of the different aspects, and
Sure.
that's a really important thing to keep in mind because. Um, a lot of the research that is funded currently is extremely specialized and looks at a very tiny slice of the problem. But every decision that is made, for example, for the built environment, as I intended as construction, it does affect all of the other aspects of our life. And
Yes.
so when you want to really tackle a complicated problem, climate change, wildfires, all of these kind of things, you really need to have a group of people that are put together, start developing a common terminology, a common dictionary, because, uh, you know, I've been directing a large project for UCOP, the University of California Office of the President, on wildfire induced air pollution assessment and mitigation. And in this team, we had physical scientists that were modeling fire spread and all of those kind of things. Then there were engineers that were how do we develop technical solutions that improve the resilience of our built environment and reduce the risk for other assets. And then there were people that were investigating air pollution, smoke, emissions, how they transfer in the environment, how they transform chemically. And then there were medical and epidemiologists and medical personnel that were investigating the effects of this smoke on individual and population health outcomes. And then a lot of plant science and all of that. But we had we spent the first year really just developing a common terminology, because when I talk about design, I talk about drawings of a home or buildings of a bridge. But when an epidemiologist talks about design, they are thinking about the type of population and how to divide the different cohorts and what are the data that needs to be collected from the hospitals. So even just being able to look at the problem requires a lot of work together. That is before you can even start doing meaningful research.
And where did you put this?
Yeah, sorry.
So you said you developed a common dictionary, so to speak, lexicon.
Our project in order for the
right.
20
And is that something that's available that I could look and I could see, what what your lexicon is?
Yeah, we didn't put it together for public consumption. Maybe we should plan about doing something like that. But that's part of the issue that I was bringing up. These type of efforts that are not directly publishable, they typically are discounted in the way that research is funded right now. And so it becomes very difficult, because it means now we have finished our project. We need to go back and do that extra work. Any type of work requires hours of work for the students, for the professors, for the researchers. And it's not something that you can do. And there is a problem that comes also for collecting but maintaining the data. Typically, funding for collecting data is relatively not easy, but easier than other things to get. But then maintaining that data, making it so that everybody else can use it for other applications, that's something that is simply not funded. No one looks at it, and that's definitely not an efficient way of using our resources.
I see. And so we talk about siloed knowledge in the fire community, and it's not necessarily as people might think, because I want to keep my information to myself and you can't look at what I did. It's just simply that the budget hasn't been put in place to make the information public.
Yes, and typically there is not a system to fund these type of efforts. So, I mean, typically what happens is you do the research, you put out all of your data, curated as much as you want, you put your metadata, but then the student graduates, because everybody needs to go ahead with their life, and they are not available anymore to help someone that wants to use that data. Now, typically, if I prepare data for structure performance, people that are within the structural engineering community will be able to use it, because we kind of already use a similar terminology, and we speak the same language, so to speak. But for example, a lot of the data that I've been using for structures is very useful also for emission assessment.
I see.
It can be used to understand what is emitted by a building when it burns. Now, in this particular case, I worked with the colleagues because we wanted to have that capability, but the students are not there. So if someone wants to use it for a different application, it will be very difficult for them to get the data in the right format for what they need. So they end up finding much easier and more efficient to just recollect all of the data,
I
which
see.
at the societal level is not the most efficient way of doing it.
No.
It's just the most efficient within the budget that you have given, because you can only investigate that.
I see. Wow. Otherwise, someone would have to track down a professor who had the time to put that data together for them.
The starting point of your sentence is already making it impossible. You will not track down any professor that has any time. We are overloaded with 12 different jobs that are all within each of our jobs, because we are teaching, we are doing research, but we are also PIs, which means we are fundamentally the CEO, CFO, and the COO of a small company that is our research lab. And then we have all of the other teams that are coming with service and work within our agencies or universities. So the only way for us to have time is to have funding that supports someone to work on something.
Work on Sunday. Okay. Yeah. That's a
And
big
that is
challenge.
always very, very specific.
Yes. So this is really an obstacle to the research that you're doing being implemented in, in the private sector.
But that's a more general problem
Yeah, not
of
specific
all
to
of
you.
research, because it's within different fields of research, and also in the transmission to private sector investment and all of that. Now, if we talk about the more specific problem that I'm trying to address for my own research group, that is how do we make earthen construction mainstream? We have a lot of issues that are unresolved. First of all, we are working now with the Masonry Society to develop a nationwide building standard for construction using earthen materials. And that's a big issue right now, because fundamentally what happens is that there is not a nationwide building codes, and there are some chapters or appendices of the International Residential Code or International Building Code that can be used, but with very strong limitations. So fundamentally, when you go to a building official, they will automatically tell you no if you want to use something that is different from the baseline type of construction.
Right.
Then if you want to do that, typically you need a professional engineer and an architect and probably something more just to get the permit. As a result, in the US, there are about 100 to 200 homes that are built with this material each year. And typically these are multi-million-dollar villas, even though the base material is actually cheaper than any other material because it's soil. So take a shovel, you find it under your feet in almost all cases, unless you are building on the delta of a big river and then you need to move a few miles away. In all of the other places, the soil that you have under your feet, it works wonderfully for any type of construction. So that's kind of the baseline. But then also the supply chain doesn't exist. So if you want to have a builder that is able to build with this material well, I had to work with a friend from Los Angeles to be able to build here in Davis a structure that I needed for a test. So it's very different than just looking to any of the companies that would be able to build this house. Also, the fact that we don't have a standard fundamentally makes it that every single structure needs to be treated as an independent structure that needs to have a professional engineer and an architect design, which is very different from having one drawings that works for 10,000 homes, and then you tract build them with no additional design costs. Also, the material right now, if I have to buy the material instead of making it myself, there are some people that sell it in Colorado, some people that sell it in Texas, but not a lot of things available here in California. There is a group that works with Super Adobe that has had some success in selling that material, but we are still talking about few hundreds, and we really need to go into the millions. So all of these things are issues that, in my opinion, require a little bit of support from outside, because we are in that phase of the free market where there is a big potential of ending up with something better than what we have. But that climbing that hill until you are at the same level with something that has already supply chains, builders, everything aligned, because for 60 years we have done it only this way. 95% of the homes that are now in Northern America are wooden homes. Is something that will not happen just with the free market. It has to have a push. Like we had a push for solar, and now solar is fundamentally the first source of energy almost everywhere, or at least the one that is growing faster than anything else because it's cheaper than everything else. We need that help. We needed the help to catch up with about 100 years of research that was funded by industries like concrete, steel, and timber. We need help with developing designs that can be used and automatically approved, like it happens for tract construction. And again, this is something that to me seems very logical, is a good way of investing public funds because it has a big return on investment. But it has to happen. Right now, there is a big opportunity for companies that are already producing masonry components to add an additional product to their list of products. You can have a green brick that is made with soil without having to burn it. They have already the supply chain, the distribution systems. Very often they have the machines that can be used, and with a little bit of research, we could change the fabrication method from compression of block by block into an extrusion type production. And then you go from producing, as we do, about 400 blocks per hour to 40,000, and now you're playing the same game as other industrial companies and industrial materials. When you are at that leveling point, then yes, free market can take it from there, but there is too much of a difference right now.
I see. So it's going to need a little bit of funding to get it to the point where it can be commercialized.
It needs funding, it needs education, because architects, engineers typically don't study earthen construction. 200 years ago, we were building with that, but then most of the literature is gray literature. It's not in the same type of research that was funded by a company or by an industry to advance it. And so it's a little bit more difficult to present it until it becomes more institutionalized.
Yeah, well, that's an uphill battle, isn't it? But one that we need to do because so many benefits.
I mean,
the question is how quickly the benefits come, right? And unfortunately, in America, will the benefits come within the 4 years of my term? And am I willing to do something that benefits future generations, but it might not get me elected this term?
That's another layer of problems that is definitely a reality to live with. But there is also the other side of the medal. That is, if we don't do anything, people like Powell are saying that in 10 to 15 years, we will have entire regions of the US where there won't be insurances for homes. And as I discussed before, no insurance means no mortgage, which
Right.
means no more construction. And a crisis that will be worse than the 2008 that we already had. So when we are marching full speed against a wall, I think someone has to push the brakes sometime before we hit it. Otherwise, I don't know what remains after.
Yeah. So do you feel a little divided because on the one hand you're doing this, physical scientific research, here are the materials that are developed, they're, either less flammable or non-flammable in, normal conditions. And then knowing at the same time that the benefits of the physical things that you build can't be implemented unless all these other aspects of society change to make room for them.
I don't know if I'm divided. I mean,
Or it's
definitely
frustrated, I guess.
there is a level of frustration in that,
Frustration.
but that's what I think is part of research and education. I mean, as a professor, most of my time is spent by developing new knowledge and educating the next generation of engineers. And both of these aspects of my job provide a lot of satisfaction in doing it.
Yes.
And they are spurred by curiosity on one side and the will of giving back. So I could do something else and probably get much more money by doing something else, or even research something else and get much more accolades for what I do, even though I know that in the long term I will have less impact. But I do this job because I want to have an impact. And so I'm figuring out what are the other things that need to be aligned in order to reap the benefits of the research that I'm doing in my lab. And I'm trying to find ways to communicate it, like the podcast we are doing now. I'm trying to find other allies that can address these issues outside of my field of expertise. So how do we change policies in a more efficient way so that we go from ignition resistant homes to fire resilient homes? Uh, I'm not an expert in policy, but there are colleagues that spend their
Yes.
career doing that. And so I'm looking at trying to build a multidisciplinary group that can holistically look at the problem and provide a realistic path forward to implement them and benefit society. That's really the only reason I'm doing this job, because if I was doing it for economic reasons, probably I should revise the way that I look at my life, because this is not the most efficient way of getting money.
No, but you're not there for the money. I understand. You're there for the benefits that your research will provide to future generations, and you get to work with the next generation as a professor. Tell me what that's like. Um, there's sometimes a disconnect between generations, and then other times where there's a commonality where you see you're both driven by curiosity and by a passion for invention. What do you see with your students? What are you more annoyed with them, more fascinated by them? Sometimes both.
So I wouldn't really divide it into generations. There
Okay.
is such a huge variability from individual to individual that is you can find some commonalities across generation, and definitely the new generation, or at least the one that I'm interacting now,
Yes.
young people in their early 20s, they have a higher sensibility to issues related to what is going to happen to my planet,
Yes. Thank
which
you.
is a good thing. But again, the variability of individuals trumps the variability through generations. And so there are people that are driven by curiosity, by the 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 the, the joy of discovering something for the first time, and they will always exist, and they are the one that fundamentally uh, thrive within a research environment, or at least should thrive within a research environment. Those are the people that can really make the difference for our future, and even for our present. It's typically, there are always parts of the job that are less enjoyable and more enjoyable. Interacting with the young generation is one of the parts that is, in almost all of the cases, the enjoyable part. Grading, I don't like it too much, but teaching and having nice discussions and looking at different viewpoints, that's what really makes it, different
Sure.
than other type of jobs that I could have done.
Yeah, and I know, obviously you think I agree. I think your research is important. You think your research is important, but eventually there won't be a Michele Barbato anymore, right? You'll move on, and then it will be up to the next generation whether they continue that nature of research. So when you work with your students, are you encouraged that at least some of them will continue the type of research that you're doing?
So when I look at the issue is not so much to continue the research that I'm doing. I actually hope that they will find their own path, and
Yes,
their own things that they're really interested in, because not necessarily what I'm interested in needs to be what they are interested in. Although there is typically an alignment with the graduate students that are working within my group. Otherwise, they wouldn't be coming and working with me. Um, what I look for is really giving them the same type of passion, interest, curiosity, um, learning how to do your work ethically, and it's more the process that I try to instill to them than the specifics. The
sure.
specifics, they are brilliant people. They can figure it out themselves. But I try to provide from my side a way of looking at research that sometimes is not the mainstream, which is moving too much, in my opinion, toward the metrics and bean counting.
Yeah,
The reason of doing research is not to publish a huge amount of papers that have less value than the paper they are printed on. You really want to have something that is making, even if it is a small difference, but is making a difference. Because otherwise, there are much better ways of getting accolades and funding and money and being recognized in the world. This is not exactly the easiest path. Not that
no,
there is any easy path anywhere. Everything well done is difficult. But in my opinion, research is still a question of curiosity and grit. You need to be curious, and you need to persevere even when you see the entire world coming in the other direction and you're the only one walking down that way, and say, but I know this is the right way of doing it. And when you look at history, all of the people that you see in the books are people that found their own way. They weren't just following the other sheep. They were,
right.
this is my path, and I believe in it, and I'll follow it till the end.
So the two qualities you loved were persistence and curiosity. And I have three boys. That's always what I tried to instill in them: persistence and curiosity. Are there ways that you're aware?
Behavior and
And
ethical
what?
behavior.
And ethical behavior. They're
That's the other
teenagers.
thing
So,
that is crucial, in my
yes.
opinion, for anybody that is doing not only research but any type of job, work, contribution to society. Ethics is the other pillar that is needed in order for your contribution to actually be meaningful.
So how do you think, and there's nothing to do with the structural engineering, but how do you think we can go about fostering a greater sense of curiosity in students, and then matching that with persistence so that they can pursue their curiosity?
But persistence and curiosity very often are again something that you are born with, and you can be educated in a certain way. But if you are starting to be educated to that when you arrive to college, I think it's a little bit late. So it's part of the job of a family to help their children to get a sense of the importance of these aspects of curiosity, persistence, and ethics. You won't change it once you arrive in college. Now, definitely, we need to nurture them, because it's very easy to kill any of these aspects if you give the wrong model, if you give the wrong experience, and if you start fundamentally telling people, oh, the only way to succeed is by doing it this way, that doesn't require curiosity, persistence, or ethics. And we have examples in all of the fields of people that have acted unethically and have been rewarded for their bad behavior.
Yes.
So all I can really do is, in all of the aspects of my work, teaching and research, is promote independent inquiries and desire to discover something, even though it may be different from what I believe is the right solution. Many times I have learned things this way. Many times I was right, many times I was wrong, and you need to be open to that and humble enough to not only accept it but embrace it. For persistence, the only way I have to do it is, hey, this is me giving you an example of what persistence is. And, if you don't like it, but probably you need to look for something else that doesn't require that level of persistence. But again, if you want to be successful in any field without persistence, it's going to be very, very difficult. You need the level of luck that is typically not that common. So even if it is hard, persistence may be the one property that in average ensures your success more than any other type of quality that you may or may not have. And so the way I do it is direct example. Same with
That's more
ethics.
right. We would not have light bulbs, right? If Edison wasn't so insane to continue after the 900th and the 1000th and the 1100th bulb until he got it to work. Right? It's persistence that gets it.
Absolutely.
Yeah. Do you have kids?
I have one daughter.
Okay. And so you said that if we're going to have curious students, then that has to start at home. How do you instill curiosity in your daughter?
Well, first of all, I try to expose her to the type of research that I do. When we break something, I tell her, you want to see how we break it. And typically that's, something fun. Now we are developing a technology based on earth blocks that is fundamentally giant Lego blocks, so that even kids can build their own house. Um, we have they made the big blocks that we use for real homes that are like these, but I also have made the smaller blocks that are like that, and you can make kind of a doll house that is resistant to hurricanes, tornadoes, and wildfires. Um,
So someone's
you
house
know,
could burn down, but the dollhouse would still
the
be there.
doll house will be there.
Barbie is safe.
I gave her for her ninth birthday the first samples of Martian blocks that we have created in our labs. We have developed Earth blocks like, but Martian with the regolith simulant of Martian soil in
Oh,
our
wow.
labs, and so she has the first ever Martian block, and hopefully 20, 50 years from now we'll be building on Mars with my blocks, and she will have something unique.
That'd be right, because we're not going to ship concrete up there,
We are not going to to ship
or
concrete.
fiberglass or
No.
wood or anything else, right?
So we have
We're
developed these blocks that are done only with material that is available on Mars, and they have a strength that is double the one of concrete.
wow. And
And
are those materials also available on Earth?
I mean, it's fundamentally the same type of soil, with the difference that on Mars, you cannot use water that you're bringing from anywhere. So we are getting the water from the material itself, and that
I see.
works as our binder. On Earth, you can use water, you can use cement, you can use lime, you can use a lot of other things that are not available on Mars.
I see. Wow. Big, big, big things to think about. How do we build on other? Well, I guess we figure out how to build on Earth first.
Well, we need to improve the way we are doing it because we have lived for many decades considering, oh, we have solved our problems. And then we started having the climate change on us. And I mean, again, it's not the only problem. For wildfires, there is a myriad of different issues between, there is definitely climate change, but there is also the increase of vulnerability because we need the new places where to build. And we have done for about 100 years a very aggressive policy of fire
Suppression. Yeah.
suppression that
Yeah.
has increased the fuel. So again, typically these problems are much more complex. You cannot identify a single reason and a single solution. You need to consider the interaction among different things. But now things are changing. They are changing faster than the existing technologies can adapt. And when that happens, it doesn't make sense to try to adjust things at the edges, which is the typical approach that is taken whenever there is a new problem. Can we just optimize what we have already been doing for long? I'm at the point that I believe this is not where we are at. We really need to rethink it. We need to be open to different solutions. Personally, I believe that earthen construction for buildings that are 1 to 2 stories is a great solution that should probably be used on a very significant part of the market. There may be other solutions that develop in the meantime and that may be even better. Although 10,000 years of successes is kind of a difficult thing to beat. So I think
You,
I
you
have a
know,
pretty good case.
yeah, I think, for most people in the science community right now, they feel like, the political climate is working against them. But,
It does.
and I want to ask you to comment on that. I know you have to keep your job, but I guess I have to keep my job too. But, well, I pay my own salary. But, but what I'm wondering is earthen construction and earthen bricks are domestically produced product. And so there might be some political advantage right now for looking at building homes with things that are not imported. And if the cost of imported goods is going up, then that makes it even more attractive to consider the domestically generated product.
That is absolutely a consideration that I've been making. Yes, we are all aware of the current political difficulties for any research that is related to climate issues. It's part of the persistence that we were discussing before. If I had to
That's
stop every time I had a problem, I would have changed career 20 years ago, not now. So I'm going to continue doing what I believe is the right thing to do. And when there are opportunities, and if tariffs become an opportunity, then we will use that opportunity.
absolutely
Not counting on any particular ingredient to be again the solution of all of these things. But if there is a situation that ends up being a positive, I think that is something that has to be used. The other big lever that I think will have an important place in understanding that the only solution for the insurance wildfire housing crisis is reducing the risk are the insurances. The insurance industry has a big lever, has definitely the capacity. It's just a question of having the will of they have been very successful in pushing the construction industry, for example, in Florida, in making better homes for wind actions. In the AC7 standard that is used everywhere and is produced by the American Society of Civil Engineering, we have started designing homes for 700 years return periods, with important constructions that are at 1700 or 3000 years return periods. That has not happened for floods. We only recently moved from the 100-year to the 500-year flood type of thing. And that is because for several decades, flood issues were addressed by the federal government. And apparently, federal money is money that appears from nowhere because people are much more happy to use it for solving problems than private money. So we have been designing for 100-year return periods for flood, while we were designing for 700 years for wind, because the wind, the insurance industry said we are not going to pay anymore unless you build better. Maybe we should do that also for wildfires and flood and all of the other hazards, because there is a level that actually makes sense at the societal point of view.
Yeah, well, between the tariffs and the insurance companies pushing, towards what you're doing, you can swim further when you're swimming with the river, right?
Absolutely.
So
Also,
I
it's
hope
much more enjoyable.
yes, that's right. You feel your
It's not that
progress.
I like to suffer for the sake of it. It's just that right now I believe I'm pushing a little bit against the current because I think it's the right thing to do. But
Yes.
if the current start changing, I'll be the happiest fish in the river. I'm already in the right direction. The other have to turn around.
Look forward to watching you swim. Thank you so much for joining me on the fire break today. It was great getting to chat with you and learn about you.
Yep. It was my pleasure. Thank you for having me. And I look forward to other opportunities to chat and work together.
Me too. Michele Barbato at UC Davis. UC Davis? Yeah, UC
Yes.
Davis in California, doing some fascinating work in structural engineering and thinking forwards the way the natives did here when they did things and they thought 7 generations ahead. That idea is not dead. I'm very happy to see. You've been listening to The Fire Break. I'm Steve Wolf. We're sponsored by Team Wildfire. We'll see you at the next one. Until then, be careful.